You probably assume evolution is a one-way street. Species get smarter, more capable, better armed against the world with every passing generation. That's not what happened to one of our closest known relatives. A new study, published in July 2026 in the journal Science Advances, suggests that a human species survived on an isolated island for well over 100,000 years. By doing something that sounds like a downgrade, not an upgrade, they stopped hunting almost entirely, gave up controlling fire, and lived largely off the leftovers of a giant venomous lizard. This isn't a story about humans getting smarter over time. It's a story about a species that may have actually lost capabilities other humans already had and somehow survived anyway. Today, when you picture human evolution, you probably picture a straight line, upright walking, then tools, then fire, then bigger brains, then civilization, each step building on the last. It's a comforting story, mostly because it matches how your own life feels: better tools, more knowledge, steady improvement. But the fossil record doesn't actually promise that kind of straight line, and nowhere is that clearer than on a small Indonesian island called Flores, where one of the strangest human species ever discovered lived for more than 100,000 years, doing almost the opposite of what you'd expect an advancing species to do. Here's the background you need first. In 2003, archaeologists excavating Liang Bua Cave on Flores uncovered the remains of a hominin unlike anything found before. Standing at roughly 1 meter tall with a skull about the size of a grapefruit, the species was formally named Homo floresiensis, but almost immediately picked up a nickname that stuck: the hobbits. Alongside their remains, researchers found stone tools and the bones of stegodon, an extinct dwarf relative of elephants roughly the size of a large bison, evidence that seemed, for 2 decades, to tell a fairly clear story. Small humans, using tools, taking down large prey. It fit the existing narrative of human evolution well enough that most people accepted it without much scrutiny. Small body, sure, but still a hunter, still a toolmaker, still recognizably capable in the way we expect human to mean. Now here's where the belief gets challenged. Paleoanthropologist Elizabeth Grace Veitch, a researcher with the Smithsonian's Human Origins Program, decided to actually test that hunter narrative rather than assume it, and the method she used is almost as interesting as what she found. Her team studied fresh tooth marks left on goat bones by a live Komodo dragon at Zoo Atlanta, essentially creating a known, modern reference sample of exactly what a Komodo dragon's bite pattern looks like on bone. Then they compared those marks against more than 3,100 fossilized stegodon bone fragments and roughly 7,000 rodent bones recovered from Liang Bua Cave. What they found upended the hunting story completely. The Komodo-style tooth marks were concentrated on the meatiest, most valuable parts of the stegodon carcasses, exactly where you'd expect a large predator to feed first. The stone tool cut marks made by Homo floresiensis, by contrast, were concentrated almost entirely on the leftover parts: ribs, feet, the low-value sections a predator leaves behind once it's already eaten its fill. In other words, the sequence wasn't hobbit kills stegodon, then eats it. It was Komodo dragon kills stegodon, eats the best parts, and then Homo floresiensis moves in afterward to strip whatever meat remains from the scraps, much like modern Komodo dragons still do today when hunting water buffalo on the same islands, delivering a bite and then waiting for the prey to weaken and die before feeding. Researchers believe the ancient dragons handled stegodon the same way, and the hobbits simply waited their turn. And the reversal doesn't stop with hunting. The same research challenged something else that had been widely assumed about Homo floresiensis: fire use. Earlier interpretations of dark staining on some of the Flores bones had been read as possible evidence of burning, controlled fire, cooking. Veitch's team went back and specifically searched for burned bone among the stegodon remains and found none. They then examined more than 4,000 additional rodent bones from the same sediment layers, again with no burn evidence. The dark discoloration researchers had previously pointed to turned out to most likely be manganese staining, a natural mineral process, not soot from a campfire at all. Put together, the evidence increasingly suggests Homo floresiensis may not have reliably controlled fire at all, something every other well-studied human species, including Homo erectus and Neanderthals, had mastered long before. Here's the thing that makes this genuinely disorienting rather than just a minor correction. Homo floresiensis wasn't some early, transitional, pre-human species that simply hadn't developed these abilities yet. Current dating places their presence on Flores from roughly 190,000 years ago until around 50,000 years ago, meaning they were alive at the same time as Neanderthals in Europe, Denisovans in Asia, and eventually Homo sapiens, all of whom had fire under control, all of whom hunted large game directly. Homo floresiensis existed in the same broad window of time as species with dramatically more sophisticated survival toolkits, and yet apparently got by without two of the capabilities we tend to treat as basic markers of being fully human. So why didn't they need those capabilities? This is where the story stops being just a myth bust and becomes something genuinely fascinating about adaptation. Flores is a small, isolated island, and islands do strange, specific things to the animals that end up stranded on them. A well-documented biological pattern called island dwarfism, and its flip side, island gigantism. Large mammals that get isolated on islands with limited resources and few predators tend to shrink over generations, since a smaller body requires less food to sustain in an environment that can't support large populations of big animals. Stegodon itself is a textbook example, a dwarfed descendant of much larger mainland elephant relatives. Meanwhile, small animals on islands, freed from the predators that would normally keep them in check on the mainland, sometimes grow larger instead, filling ecological niches that would otherwise belong to bigger predators. Flores had its own dramatic version of that pattern too, sitting at the very top of the island's food chain. The Komodo dragon, the largest living lizard on Earth, capable of killing prey many times its own size using a bite loaded with venom and dangerous bacteria. Put those pieces together and a very different picture of Homo floresiensis starts to emerge. Not a failed or inferior human species, but a highly specialized one, shaped by an unusual island ecosystem into a role that simply didn't require the same toolkit other human species needed elsewhere. If a far more efficient apex predator was already doing the dangerous work of taking down the island's largest prey animal, there may have been no strong evolutionary pressure pushing Homo floresiensis toward developing sophisticated hunting techniques of their own. Why risk direct confrontation with prey the size of a small elephant when a nearby Komodo dragon will do the killing and all you have to do is wait, then move in with a simple stone flake to strip whatever's left? Some researchers studying the find have pointed out that modern Komodo dragons rarely attack humans unprovoked, which may mean this coexistence, hobbits shadowing dragons for scraps, wasn't nearly as dangerous a strategy as it might sound at first. Anthropologist Brianna Pobiner, who was involved in interpreting the findings, has noted that Homo floresiensis likely survived on a mixed diet of scavenged raw meat alongside plants and insects, persisting on Flores for well over 100,000 years despite living directly alongside the animal that controlled the top of their food chain. And the fire question fits into this same reframing surprisingly well. Controlling fire is metabolically and behaviorally demanding. It requires consistent fuel sources, maintenance, protection from rain and wind, and transmission of the skill across generations without interruption. If a population's survival strategy revolved primarily around scavenging raw meat and foraging rather than actively cooking large hunted kills, the evolutionary and practical pressure to master fire may simply have been weaker than it was for human populations navigating colder mainland environments or hunting dangerous prey that needed to be processed and preserved differently. Losing, or never fully developing, a capability isn't automatically a sign of failure. Sometimes it's a sign that a particular environment made that capability less necessary than researchers previously assumed it had to be for any human species to survive. This finding is also reigniting an older, unresolved argument about where Homo floresiensis even fits on the human family tree, and that argument matters more than it might seem because it changes how we should even interpret this downgrade. One camp of researchers believes Homo floresiensis descended from Homo erectus, a species already known for tool use and, in most populations, fire control, meaning the hobbits would represent capabilities genuinely lost over generations of island isolation. A different camp argues Homo floresiensis instead descended from a much older, more primitive branch of the human family tree entirely, one that may never have developed sophisticated hunting or fire control in the first place, which would mean there was no loss at all, just a population that had never needed those tools to begin with. Some researchers involved in interpreting the new findings have gone as far as suggesting Homo floresiensis may not really belong comfortably within the genus Homo at all, a minority position, but one this new evidence appears to strengthen rather than weaken, since a small-brained, non-fire-using, primarily scavenging hominin fits awkwardly alongside the rest of a genus generally defined by exactly those capabilities. Either way you land on that debate, the core takeaway holds. For more than 100,000 years, an entire human species survived, reproduced, and persisted on Flores without two of the abilities most of us instinctively treat as prerequisites for being human at all: hunting large game and controlling fire. And they didn't survive despite lacking those abilities. The evidence increasingly suggests they survived because their environment made those abilities unnecessary, replaced instead by patience, opportunism, and a working relationship, unintentional as it was, with the deadliest animal on their island. So the next time you picture human evolution as a straight climb from primitive to advanced, remember Flores. Somewhere on that small island, for over 100,000 years, a tiny human species watched a giant lizard bring down an elephant-sized animal, waited for the dragon to finish, and then walked over in the dark, without fire, without spears, and quietly took what was left. It wasn't progress by any definition we usually use. And it worked anyway, for longer than most human innovations we consider genuinely revolutionary have even existed, which raises an uncomfortable question about what advanced was ever supposed to mean.